Okay, students, can you all hear me? Can you all hear me? Good. Right, okay. So last week we were discussing about the atomic radius. Under the atomic radius, we learned three types of atomic radius, right? So what are the three types actually we learned? Let's recall the things that we learned. First of all, we learn uh, covalent radius. Secondly, we learn van der Waals radius. And thirdly, we learned that metallic radius. So among these three methods to measure the atomic radius, I told you that covalent radius is only used to measure the radius of the elements which are forming covalent bonds. If you go for the van der Waals radius, we are taking most of the time we are taking the elements, they are not forming covalent bonds. And I told you that exact radius is less than the van der Waals radius. Exact radius is greater than the covalent radius. And I told you that metallic radius is more accurate. Exact radius and the metallic radius both are similar, right? And metallic radius only can be used to measure the radius of the metals. And then I told you that there are two factors affecting to the atomic radius. Can you remember that one? There are two factors affecting to the atomic radius. Number one, shielding effect, right? And the second factor is what? Nuclear charge. Shielding effect and the nuclear charge are the affecting factors for the atomic radius, right? And I told you that when you consider the shielding effect, when shielding effect increases, atomic radius will increase, right? So what is the connection between the atomic radius and the shielding effect? So when the shielding effect increases, atomic radius increases. And when the nuclear charge decreases, atomic radius increases. So this is the relationship you have to understand, right? So these are the two parameters actually we are trying to use in order to measure in order to compare the atomic radius, right? And then I told you that together, right, by combining these two factors, shielding effect and the nuclear charge, we can take effective nuclear charge, ZFF. Effective nuclear charge is actually the combination of these two parameters. Effective nuclear charge is equal to Z minus S, right? Effective nuclear charge is equal to nuclear charge minus shielding effect. So that's what I told. Sometimes in order to compare the radius, we can use effective nuclear charge, right? So effective nuclear charge is inversely proportional to the atomic radius as the nuclear charge, right? So the difference between the nuclear charge and the effective nuclear charge means effective nuclear charge is actually made by combining the nuclear charge as well as shielding effect. So that's how the effective nuclear charge is made, right? And last week we learned very important thing, which means when you go down to the group, right? So this is one of the very important things that we learn. When you go down to the group, atomic radius increases. I told you that reason is number of energy levels are increasing, therefore atomic radius increases. So these things are very easy, right? Logically you can think about that. Down to the group, atomic radius increases. And then I told you that along a period from left to right, what will happen to the atomic radius? Atomic radius is decreasing, right? So along a period from left to right, atomic radius decreases. Radius decreases, right? So these are the things that you have to remember. We calculated the effective nuclear charge of these elements. For example, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. For those elements, we calculated the effective nuclear charge. By calculating the effective nuclear charge, we compare the atomic radius. Then we observed atomic radius decreases along the period from left to right. So these are the things actually you have to remember, right? If you are making a short note, so you can include these things into your short note very briefly. Okay, so a short note means that should be a kind of a what? A very brief, very short summary that you can refer anytime before go for the examination, right? So that will be helpful for you, right? So that is also one of the method that I'm going to tell you to follow in order to remember or memorize these things, right? So now by now you have learned a lot of things. Right? So how we can remember these things, how we can memorize these things. So prepare a short note by yourself. I can prepare a short note and give, right? But it doesn't work, right? You have to make the short note by yourself, right? And show me, I'll tell you what are the mistakes, what are the lacks in the short note, and you refer that one, you refer that every day, right? So keep that one as a everyday practice. Then you won't forget anything. You can remember these things, what? Until your examination. You have to remember, you have to refer that one. When you are making a short note, you have to refer that one every day. Then only you can practice, right? Okay. So now today we are going to compare the radius of the ions formed by these elements, right? Okay. So if you have any doubts regarding the radius, the things that we learned last week, you can put your doubts in the chat, right? And I want to remind you that you have one more week to complete that tutorial, past paper tutorial. So I believe most of you have completed at least 70% of the tut, right? I believe. So let's see. So the deadline is 28 or before 28. So therefore, send the answers. Let's see. Okay. And the discussion will be held very soon. And the next month, paper discussion is also started. And next month, we are starting new unit. Okay. Second and third unit. So many updates are there. I'll let you know. Right. Okay. First of all, let's finish this one. So today we have to move for the page number 40, I think. We completed yeah, we have a doubt. So if we compare radius of lithium and calcium, how we can obtain it? Lithium and calcium. Okay, that's a good question. That's very easy. Look at this one. Lithium, right? Lithium, you can see that atomic number is 3. If you consider calcium, calcium is actually 20, right? So lithium electron configuration is 1s2, 2s1. So this is a doubt, okay? So that's a good doubt. Let's see. Calcium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s. So when you consider lithium atom, actually there is only, right, one principal energy level, one or two principal energy level. Lithium atom is look like this. There are 3 electrons, right, in this way. When you consider calcium, look at the calcium. Calcium is 20. Calcium atomic radius is look at this one. There are 4 principal energy levels, right? Here there are 2 electrons, and here we have 8 electrons, 4, 5, 6, 7, 8. And here also we have 8, 5, 6, 7, 8. And in the last principal energy level, there are 2 electrons. Look at the principal energy levels, right? Lithium and calcium, you can compare that. In the lithium atom, there are 2 principal energy levels. If you consider calcium, there are 4 principal energy levels, right? And lithium is in the second period, and calcium is in the fourth period. Fourth period means there are 4 principal energy levels. Lithium is in the second period, which means lithium has 2 principal energy levels. So by looking at the principal energy level numbers, can't you say that calcium has the highest radius than lithium? We can say like that, right? Relatively, yeah, relatively. We don't know what about the exact radius values. We don't know about the exact values, but relatively we can say that calcium has the highest radius than lithium because of the principal energy levels. But be careful when you are comparing the radius of the same period elements and the same group elements. Follow the rules I told you. When you compare the radius of same period elements, you have to consider that radius is decreasing according to the effective nuclear charge. When you go down to the group in the same group, same group elements, what will happen? The radius is increasing down to the group. Okay, because of the shielding effect. Shielding effect is increasing. So that means the inner shell electrons are increasing. So lithium and calcium, we can compare that one easily, right? Opeshani, yeah, Opeshani. Can you understand? So will we be able to complete the lesson today? I don't know about that one, whether we can complete that one or not. But I'm very sure that in the November first week, we are starting the second unit and third unit. Whatever happen, I will start. I told you that I will start the second and third unit in the mid of the October. Yeah, I couldn't do that one because I think we have some missed class, right? I think missing class were there, right? One day I did 2 hours, so that 1 hour is missing, and yeah, so there were some missing classes earlier. So when you calculate with them, actually we could have finished that one. But anyway, it doesn't matter. Only 2 weeks, right? So therefore, it's okay. Fine, we can start that one by November. Anyway, if I finish this one today, the next week I won't start the second unit. I will do a kind of a revision. So let's try to finish the first unit today. But I'm not. I don't know whether I can finish the unit today or not. Right? I'll try my best because my focus is not finishing the unit. My focus is actually to teach these things properly until you understand. Right? But I have some kind of a plan. I'm going in that plan. Right? So today I don't know whether I can. I will be able to finish this one. Let's see. Okay, I'll try my best. Okay. Right. Any doubts? Anything else regarding the radius? Atomic radius? Anything else? Yeah. So atomic radius affects some properties of elements, right? Exactly. Exactly. Atomic radius is affecting to the many properties of the elements. In the second unit, we are going to learn polarizing power, polarizability, metallic properties, metallic bond strength. Even in the enthalpy part also we are learning how that radius is affecting to the lattice enthalpy, hydration enthalpy, right? Atomic radius is affecting to many parameters, many things in atom elements, right? That's a good question. That's why I told you that the first unit things that you are going to learn is very important to the other units part, right? So you will learn that one very soon in the second unit. Atomic radius is affecting to many things: polarizing power, polarizability, right? Metallic radius, lattice enthalpy of the elements. So many things are there, right? So you will learn that one by the time. Okay. Anything else? Okay. If you have anything else, put your doubts in the chat box. Now let's go for the lesson. Right. Turn to the page number 40. Page number 40. In addition to the atomic radius, the ionic radius is also important in determining the chemical properties of the element. Assuming that the ion is spherical, the radius of an ion present in the solid crystal is called ionic radius. Yeah, atomic radius is also same as ionic radius. We know that there are 2 types of ions, cations and the anions. So we are going to measure how that cations radius and the anions radius, they are varying, right? This is very simple and very easy. Let's see But the issue is when you go for the questions are a little bit tricky. Okay, so let's go for the questions very soon. The following points are important with respect to the ionic radius. So let's go one by one. Number one, write down with me quickly. Problem number one, write down with me. Considering an atom and its cation means positively charged ion, formed by that atom, comma, the radius of the cation is smaller, right? Which means, look at this one, students. If I consider the element capital M, just imagine we are considering M element, capital M, and it's forming cation M plus. So can you guess who has the highest radius? For sure, M element should have the highest radius. Why? The reason is M plus means one electron is removing, right? So removing means, so kind of a what? Capacity is what? Increasing. That means the now one electron is removed means what? A new space is created. That means it's becoming smaller. Can you understand? So just imagine sodium and sodium plus cation, right? So we can take nice example for this one. A simple example is sodium and sodium plus. So sodium atom is greater than the sodium plus cation, right? The radius of the sodium atom is greater than the sodium plus cation, right? Sodium atom is containing 3 principal energy levels, right? After removing the valence shell electron, it has only 2 energy levels. So won't it reduce? The radius won't it reduce, right? Definitely it will reduce, right? So here 2, right? This is the way you can understand that one is. Now sodium plus cation is becoming like neon atom, neither. So therefore sodium atom has the highest radius than cation. That means always we can consider that as a theory. As a theory, we can remember that if you consider a particular atom and its cation, always the elements or atom's radius is greater than that cation's radius. Okay. Okay, right. Okay, I think there are some connection issues. Okay, let's see. Now, can you all hear me? Right, okay, good. So what we were talking about? This one, right? So considering an atom with its cation, so we can see that always radius of the cation, and if you compare the radius of the cation and that element, always that element has the highest radius than the cation. So that is kind of a theory that you have to remember. So I explain you why is that after removing the electron, the size is reducing. Therefore, we can consider that, right? Okay, quickly write down this one. Yeah. So what about elements with more than one electron in the valence shell? That doesn't matter. If there are more electrons, same thing. Just imagine magnesium and magnesium 2 plus. Magnesium and magnesium 2 plus. Same thing will happen. Magnesium has the highest radius than magnesium 2 plus. If there are two electrons, aluminium and aluminium 3 plus. Who has the highest radius? Aluminium. Right? Always when you compare the cation and its element has the highest radius than the cation. Okay, Asma, can you understand? Right. Okay, right. Now let's go for the second Rome number. Rome number 2. Rome number 2. So write down with me in this way. If an element is forming several cations, the radius of the cations is depending on the number of electrons removed by the atom, which means higher the charge, higher the charge, lower the radius, right? Look at this one. If I consider iron element, right? Remember, students, this is element iron. It's forming two cations. I have taught you this one when we discussing about the electron configuration. Also, I taught you this one. Iron is forming two cations, Fe2 plus and Fe3 plus. Fe2 plus and Fe3 plus cations. Fe2 plus is ferrous and Fe3 plus is ferric. So this is ferrous and this is ferric, the name of the cations, and the element is iron, right? So if I consider Fe, the element, and Fe2 plus and Fe3 plus, now tell me, right? If an element is forming several cations, the cation's radius is depending on the number of electrons removed, right? Depending on the number of electrons removed by the atom, which means higher the charge, lower the radius. When the charge is very high, we can consider that radius is very low, because here the number of electrons removed by iron is 3. That means this cation should have the least radius. Neither. So the here in Fe2 plus we can see that number of electrons removed here is 2, which means this should have the greater radius than Fe3 plus. But anyhow, we know that from the previous theory, if you compare the any cation formed by that particular element, the element's radius is always greater than the cation's radius. Therefore, we can tell that Fe has the highest radius than Fe2 plus. Fe2 plus has the highest radius than Fe3 plus. Very easy. Okay. So as an example, quickly write down this. These things are very easy, right? Nothing, quickly. Quickly. So this is Rome number 2. They have given. Done. Now let's go for the Rome number 3. Rome number 3 says that if you consider the element and its anion, now we are talking about the anions, right? Considering an atom, I'll change the statement here. Considering an atom and its anion. Anion means the negatively charged species formed by the atom. The radius of the anion is greater. Greater, right? Let's see. If you consider anion, let's consider the element is capital A, right? Element is capital A. If not, I'll take capital N, capital N. And its anion is N minus, right? Now, logically, which one is greater? Definitely anion. What is the reason? We know that one. If you consider an atom and its anion means the species which are gaining electron. Gaining something means now capacity is full, right? So therefore, the radius is increasing. Very simple. Same element, nothing changes. Number of protons, anything won't change. What is the only different factor affecting main? What is the increasing factor? The electrons. So if the electrons are increasing in the same element, we can say that radius is increasing. Therefore, let me consider that as an example, chlorine and the chloride anion, right? Who has the highest radius? Definitely chloride has the highest radius, right? In the cation case, we consider that the cation and its element, if you compare them, element has the highest radius. In the anion case, if you compare the element and its anion, definitely the radius greater in anion. Okay, quickly write down this one under the row number 3, quickly. If you have any doubts, put your doubts in the chat box. So if the electrons in same subshell gonna remove or added, it's not gonna affect to radius, no, we can't tell like that, right? We can't tell like that because just imagine the nuclear charge felt by, right? The nuclear charge felt by the atom, it's affecting to each and every electron inside the atom. Whether it is in the valence shell or inner shell, doesn't matter. The nuclear charge is affecting in somehow to each and every electron, right? If you remove electron, just imagine you are going to remove electron. If you are removing electron means, so the electron means kind of what? Shield, we discuss about that one. Electrons means kind of a shield, a protector. If you are removing electrons, it means something losing, right? Even it's in the valence shell, if you are removing electron means something we are losing. So if we are losing something, we can tell that that is reducing, radius reducing, decreasing, right? If we are gaining one electron, we are gaining an electron against the nuclear charge, right? We are gaining electron against the nuclear charge, which means we are increasing our capacity. That means the number of electrons are high. The shield is strong now. That means the radius is high. That's how we think. Yeah. So your logic is correct. I can understand that, right? So he is asking that. So others also listen to this one. He is asking that how it can affect to the radius if we are removing electrons from the same subshell, right? If you are removing that out, Fe3 plus and Fe2 plus, if you consider that there are, I think, 6 electrons, as I can remember, yeah, 6 electrons in the valence shell. If you remove first electron, second electron, okay, and the third electron also belong to the same energy level. So how it can affect to the radius? It is affecting. because each and every electron that we are going to remove here is actually under the nuclear attraction force. So we are removing electron from the nuclear attraction force. So definitely that should affect to the radius. That is kind of a balance, Senura, right? The number of electrons and protons inside an atom is a balance. You are removing electron or gaining electron means you are unbalancing that. So that unbalance is affecting to the radius, isn't it? So that's something, okay? Try to understand. Anything else? Good. Right. Now let's go for the problem number 4. Problem number 4. Those who are missing today's session, done, okay? Live session, because very important topic that we are going to discuss. The next one is ionization energy. Those who are trying to miss this one, okay, very good. Keep it up. Right. So that's very important. Don't miss that. Right. Number 4, if an element is forming several cations, the radius of the, let's change this one into anions. Now, in the case of anions, the radius of the anions, again, that is depending on the number of electrons, right? Number of electrons not removed. Here we have to consider number of electrons gained by the atom, which means higher the negative charge. I will put a term here, a new term. Higher the negative charge, what will happen? Higher the radius, right? Higher the negative charge, higher the radius, which means if you compare, let's assume that oxygen is making two anions, O minus and O2 minus, right? O minus and O2 minus. So which one should have the highest radius? For sure, O2 minus should have the highest radius because it's gaining electron. Since it's gaining electron, it should have the highest radius than O minus, and here neutral atom. So this is the variation. Very easy. Quickly write down this one under the fourth statement. Page number 41. Quickly. In the page number 41, students, they have already given a paragraph neither. Cut that one. That paragraph is completely wrong. Cut that. In the page number 41, at the top, I have given you a paragraph. Cut that, and above here, that means here you can write down the things that I have written in the whiteboard. And under that, write down this example. Okay, quickly. Okay, done with writing. Now they have given a question in the tutorial. Let's see. Conclude by reasoning how the radius varies in potassium plus, calcium 2 plus, argon, Cl minus, and S2 minus. In the tutorial, they have given question like this, right? Conclude by reasoning. Conclude by reasoning. The radius varies. The radius varies in potassium plus, calcium 2 plus, argon, Cl minus, and S2 minus. Students, it doesn't matter whether it is descending order or ascending order. You have to arrange this one in an order, particular order, descending order or ascending order, how that atomic radius will vary, right? So from the knowledge that you have gained regarding the atomic radius, I have given you a simple question, right? But remember, this is not a question as you think, right? If you get the point quickly, you can go with the answers. Actually, in order to get the answer, 1 minute is enough, right? Right. So try to get the answer how that radius varies. Let's see. Put your answers in the chat box. Tell me who has the highest radius, second highest one. Okay, let's do this one in ascending order. Ascending order. Let's do this one in ascending order. A simple exercise. Let's see. Potassium plus, calcium 2 plus, argon, Cl minus, and S2 minus. How the radius is varying. Arrange these species in the ascending order. Very simple thing. Nilukshika, correct. Very good. Very good. Yes, I'm getting some answers. See, I told you. 30 minutes are enough, right? Nilukshika, you are correct. Senura, you are correct. Very good. Sandul, correct. Sarina, correct. Yes. Sinetma, Sinetma, there is a small mistake. Check it again. First two is wrong. Sinetma, check it again. Those who send the answers, others, you are correct now. Very good. Okay, right. So since most of you have completed this one, so others also send the answers in the chat box, right? Let's see. Very easy. Michelle, check it again. Sinetma, now correct. Yes, now you are correct. Okay, good, very good. Sandeep, correct. All are equal. Zina, wrong. How that all are equal? But that's a good try. Sandeep, correct. Right. Let's go for the answers quickly. Very easy. What is the specialty of the given species? Amshi, wrong. Check it again, but good try. What is the specialty of the given cations, anions, and the neutral atom list? What is the specialty of these things? I have given you 5 species. All have 18 electrons. Yeah. If the all electrons are same, what is the name I told you? Annahari. Very good. Isoelectronic. isoelectronic series. All of the species I have given you here, they are in an isoelectronic series. First of all, you have to understand that term, right? So I can see that potassium plus, right? Potassium is atomic number 19. After removing 1 electron, there are 18 electrons. Calcium 2 plus, atomic number is 20. After removing 2 electrons, 18 electrons. Argon is neutral atom. Atomic number is 18. That means number of electrons are 18. Chlorine atomic number is 17. After gaining 1 electron, number of electrons are 18. Sulfide atomic number is 16. After gaining 2 electrons, electrons are 18. So all of them are in an isoelectronic series. Isoelectronic series. That's what you have to understand here. Isoelectronic series. Isoelectronic series means all of them have 18 electrons. Right. So this is the simple thing that you have to notice. Right. So if you can understand this one, you can easily go for the answers. Remember, students, the most of the MCQs, right? Most of the MCQs are like this only, right? You don't have to apply all the theories that you have learned. You have to be very tricky. First of all, you have to notice everything, right? First of all, you have to notice here the number of electrons are same. All of them are in a isoelectronic series. Remember, if the number of electrons are same, that's very easy to compare the radius. Why? You know that there are two factors affecting to the radius: shielding effect and the nuclear charge. Shielding effect means number of co-electrons, isn't it? Shielding effect means nothing else, the number of co-electrons. What do you think about the number of co-electrons of all the species? Same, right? Number of co-electrons are same. 18 electrons means, just imagine argon. So this is very, all of them are similar to argon. In electron wise, all of them are similar to argon. In the valence shell, there are 8 electrons. I'm not going to write down everything. And here also we have 8 electrons. 8 electrons. 8 electrons. And here we have 2 electrons. Right? So what is the affecting factor for, what are the affecting factors for the radius? Nuclear charge and the shielding effect. Shielding effect, is it changing? Do we need to calculate the effective nuclear charge? No need. You can just go with the nuclear charge. We know that if the shielding effect is not affecting here, we have only one factor. Neither shielding effect is measured by number of co-electrons. So how many co-electrons are there? 10 electrons. In potassium plus 10 electrons, calcium 2 plus 10, argon 10, chloride 10, sulfide 10. Because number of electrons are similar now. Therefore, shielding effect won't dominate here. Then who will dominate here? Who will dominate here? Nuclear charge. Nuclear charge is the dominant factor here, the affecting factor. So you can just count the number of protons, right? Number of protons in everyone, right? We have calcium 2 plus, potassium plus, argon, chloride, sulfide. How many protons are there in calcium 2 plus? Calcium is 20. That means number of protons are 20. Potassium 19, argon 18, chlorine 17, sulfur 16. I told you that when you compare the radius, only two factors are affecting: shielding effect and the nuclear charge. Shielding effect, it's not changing because number of electrons are similar, constant. So we can say that nuclear charge, these are the nuclear charge. If the number of protons are this, nuclear charge also same thing, plus 20, plus 19, plus 18, plus 17, and plus 16. And I told you that atomic radius is inversely proportional to the nuclear charge, right? Inversely proportional to the nuclear charge. So that's what I told you. Now tell me, who has the highest radius then? Who has the highest radius then? Sulfide. Because number of protons are 16, lower the nuclear charge, higher the radius. Sulfide has the highest radius. Then chloride, Cl minus. Then argon. Next one, potassium plus. last one, that means the least radius belong to the calcium 2 plus. Atomic radius increasing for this direction. So this is the ascending order. Atomic radius increases, right? Okay. So in the rim discussion, we are going to discuss these kind of questions. Don't worry. So let's see what are the questions we have to discuss. So within 1 minute, right, 30 seconds, you should be able to get the answers. Very easy. Is this difficult? Please raise your hand who understood this. Please raise your hand who understood this question. Please raise your hand. If you don't raise your hand, I consider that you have now. Opeshani, Sehanti, and Toshani. Do you have any doubts? Opeshani? Okay, good, right. If you have any doubts, put your doubts in the chat box, right? This is very easy. Right. If you want to copy down anything, quickly copy down. So likewise, this is a simple question. We are going to discuss many questions in next few sessions. Quickly. Right, done with writing. Okay, so ladies and gentlemen, now we have to go for the next atomic property that we are going to discuss. So radius is one of the important factor. Now we are going to move for the ionization energy, first ionization energy, right? Under the first ionization energy, let's discuss about the second ionization energy as well as third ionization energy. But we are giving the priority for the first ionization energy, right? Okay. Now let's go for the topic. Very, very important. Okay. Now you have to concentrate to this topic more than before, because every day in the examination paper they are asking at least one MCQ or a very simple question regarding the ionization energy. So the next atomic property we are going to discuss here is first ionization energy. Ionization energy. Right. So we learned the first ionization energy definition under the, I think, ionization energy analysis topic. We discussed that one already. So now again, we are going to learn about the first ionization energy. This is very important, right? In the tutorial, actually, I have given a definition. Cut that definition again. That definition is wrong. So you have to write down the definition properly by yourself, because since we have discussed this one before, right? Since we have discussed about this one, first ionization energy, I'm not going to discuss that one. I'm not going to let you write down now here. Let's discuss that one again. Doesn't matter. So cut that one, keep some space to write down that one again. Okay, so that is wrong. Okay, the ionization energy definition they have given in the tutorial is wrong. There are some typing mistakes. They have given molecules and those things. Right. So what is first ionization energy? You have learned. Just imagine I'm going to consider an element in the gaseous state, M gas, and it's removing one electron to form M plus gas R. So this is the equation. So this is known as first ionization energy, right? So the correct definition we are giving for this one is the minimum energy that is required to, right? Listen to me this one, listen to this one, right? The minimum energy that is required to remove 1 mole of electron, 1 mole of electron from gaseous state, 1 mole of neutral atom, right? Come again, the minimum energy that is required to remove 1 mole of electron from gaseous state, 1 mole of neutral atoms in order to form 1 mole of gaseous state monovalent cation. At the last I gave you at the standard state, temperature 25 degrees Celsius and pressure is 180. That is the definition I gave you. At there, can you remember, recall these things? We discussed why specifically we are using gaseous state. I told you that gaseous state particles are randomly moving here and there. So therefore, we can easily remove 1 electron from an atom. If it is a liquid state or solid state, it's very difficult to remove electrons. Because ionization means ionization energy related to the removing electrons. So therefore, in the gaseous state, it's very convenient to remove electrons. So that's why we particularly mention here gaseous state, right? I'll tell you, I'll read another time the definition. The minimum energy that is required to remove 1 mole of electrons from 1 mole of neutral gaseous state atoms in order to form 1 mole of gaseous state monovalent cation at the standard state is known as the ionization energy, right? So I didn't memorize that one. I know the idea. So if I know the idea, I can what? Match the words. Then I can write down the definition. So that's how you also have to practice that one, right? They won't ask what is the definition for the ionization energy. But just remember, these things are very easy. And one more thing I want to remind you that why we are particularly mentioned here 1 mole. Remember students, 1 mole is the simplest quantitative parameter that we are using in chemistry. In order to measure the length, we are using some basic measurements, basic parameters. What are they? Millimeters, centimeters, meters, kilometers. In order to measure the mass, we are taking milligrams, grams, right? Kilograms. Likewise, we are taking some parameters. So in order to take the measurements of the amount, right? In the 3rd unit, we are going to learn this one very soon under the chemical calculation. In chemistry, when you are measuring the quantity of a chemical, right, or any chemical solution, anything, we are taking mole, right? So in future, we are going to learn that an equation C equal N over V. Concentration is equal to number of moles divided by the volume. So this is number of moles, right, denoted by moles. Normally, concentrations are given as 0.1 moles per cubic decimeter, HNO3 aqueous solution, right? And 0.05 moles per cubic decimeter H2SO4 solution. So likewise, remember students, the mole means actually what? Kind of a basic parameter we are using in chemistry in order to measure the quantity. So therefore, always try to understand we are considering only 1 mole. So practically think about this one. We can't choose 1 atom and remove 1 electron. Right? අපිට බෑ කවදාවත් සාම්පල් එකක් අරගෙන ඒ සාම්පල් එකේ එක ඇටම් එකක් තෝරගෙන ඒ ඇටම් එකකින් ඉලෙක්ට්‍රෝන එකක් ගලවන්න බෑ. පැහැදිලි නේද? Right? You know that what does mean by 1 mole? 1 mole means Avogadro number. Avogadro number of particles are there. That means 6.022 10 to the power 23. Among these more atoms, we are taking same number of electrons from those atoms, right? So that is the way they have defined the ionization, right? For everything, there is a reason. Why we use gaseous state? Why we use 1 mole? Now I explain you that. Okay, so keep that in your mind, very important, right? Okay, anyhow, this is the ionization energy. The minimum energy, simply we can say that minimum energy to remove 1 electron from an atom. So ionization energy. So first of all, write down this equation. Cut that paragraph, write down the definition by yourself and write down this equation quickly. Now let's move for the page number 42. Quickly write down. Right. What are the factors affecting to the ionization energy? Now you know what does mean by the ionization energy. What are the factors affecting the ionization energy? Actually, there are two factors affecting to the ionization energy. The first one is atomic radius, the previous atomic property that we discussed, atomic radius. Some say is a shielding effect. Let's see. Anyway, shielding effect is also affecting factor for the radius. We can consider directly the radius is the affecting factor for the ionization energy. And the next one is electron configuration. This is very, very important, right? Electron configuration and the atomic radius. So these are the two factors affecting to the ionization energy, right? Actually, they won't ask what are the factors affecting the ionization energy. They will ask you how the pattern, right? When the radius increases, what will be the effect for the ionization energy? When the electron configuration is behaving in this way, what is the effect for the ionization energy? Likewise, only they will question, right? Right. Now let's go for the first one, atomic radius. So how the atomic radius is affecting to the ionization energy, right? Very easy, very easy. Now look at this one. I will divide this one into two parts. That means period wise, right? And group wise, right? Period wise and group wise, right? So tell me what will happen to the atomic radius when you go along a period from left to right. What will happen to the radius? Put your answer in the chat box quickly. Definitely, the atomic radius decreases, right? Atomic radius decreases. Atomic radius decreases along a period from left to right. Tell me group wise, how is that atomic radius is behaving? Group wise, what will happen to the radius? Increasing. Increasing, because we know that number of energy levels are increasing, therefore for sure atomic radius is increasing, right? Now let's say if you can remember these two patterns, you can tell me, right? You should be able to tell me how that ionization energy vary, right? So this is along a period from left to right, atomic radius decreases. For this direction, atomic radius decreases. Okay, right. And here down to the group, atomic radius increases, right? Now how is that ionization is varying along the period? How is that ionization energy varying? Can you tell me? Period means actually left to right. Okay. In the periodic table, I told you period means these are rows. Rows are the periods. Columns are groups. Okay. What will happen to the ionization energy? I1. Okay. I have some answers. Let's see. Increase along a period. Along period increase and along a group decreases. Increase along a period. Yes, correct. You are correct. Along a period, atomic radius is gonna, along a period, ionization energy is going to increase. Because as I mentioned you, we know that radius is decreasing along a period. When the radius decreasing, students, ionization energy means the ability, nothing else, the ability. Yeah, wait, Opeshani, don't be hurry. I'll teach you zigzag variation. Don't worry. Okay. I'll tell you the reason for the zigzag variation also. Wait. Okay. I know that you are very eager to learn that. Wait. Understood? So remember, when the atomic radius decreases along the period, ionization energy is increasing. The reason is the electrons are more attracted towards the nucleus. When the radius decreases, these electrons are more attracted to the nucleus. When the electrons are more attracted to the nucleus, how is it possible to remove electron? That's very difficult task, right? We have to supply a lot of energy in order to remove electrons from these kind of atoms. Compare this one and this one, right? Here we have electron and here we have electron. At the middle we have nucleus, right? At the middle we have nucleus. Tell me from which atom you can easily remove electron? This one, very large. The nuclear attraction force felt by this electron is very low. So therefore we can easily remove electron. Can you understand? But if you consider this element, this atom, you can't easily remove this electron because this electron is very close to the nucleus. Very close. If it is very close, the nucleus is actually pulling the electrons toward himself. So the electron, we can't remove the electron from that. But this one, if you consider the distance, right? Actually, the radius means the distance between the nucleus and the outermost electron, right? If the distance is reducing, that electron is more closer to the nucleus, you can't remove that electron from that atom. Very difficult. Can you understand? Think about these things, right? You should have to sense these things. Never දැනෙන්න ඕනේ. මතක තියාගන්න කටපාඩම් නෙමෙයි. පස්සේ කටපාඩම් කරා විභාගයට යන්න කලින් දැස කටපාඩම් කරනවා, right? You can study, memorize those things before the examination, right? If tomorrow examination you can memorize today, doesn't matter. Now you have to understand these things. What's happening exactly, right? So try to understand. When the electron is very closer to the nucleus, it's difficult to remove that electron from the nuclear attraction force because that electron is closely attracted to the nucleus, right? But this electron is not like that. You can easily remove the electron, which means when the size of the atom is increasing, you can easily remove the valence shell electrons, isn't it? First ionization energy means you're always trying to remove the valence shell electrons. You can't remove the core electrons. Atom එක ළඟට ගිහිල්ලා nucleus එකෙන් electron එකක් ගන්න බෑ. Can we go closer to the nucleus and take the first electron in the first principal energy? No, you can't do that, right? So always you have to remove the electrons from the valence shell. So remember always, when the size of the atom is very high, you can easily remove the electron. But when the size is very small, you can't remove the electrons from that atom. Now tell me, group wise, what will happen to the ionization energy? Definitely, ionization energy will decrease because down to the group, it's easily, we can remove easily one electron from there, right? When the size increasing, we can remove the electrons. size එක වැඩි වෙනකොට පට ගාලා electron ටික ගලවන්න පුළුවන්. හරි? size එක අඩු වෙනකොට electron ගලවන්න බෑ. Try to understand. Right? When the radius is very high, we can easily remove the electrons. When the radius is very low, we can't remove the electrons. So therefore we tell that, remember, first ionization energy increases along the period from left to right. I1 means first ionization energy. Here down to the group, top to bottom, down to the group, atomic radius is increasing, therefore I1 is decreasing. That means radius and the ionization energy has inverse proportionality. Inverse proportionality. Neither radius, atomic radius, and the I1 ionization energy. So this is decreasing, increasing. Inverse proportionality. Increasing, decreasing. Inverse proportionality. Can you understand? Size is very high means you can remove the electrons. Size is very low means you can't remove the electrons. You have to supply a lot of energy. So therefore ionization energy is very high. Right? So please raise your hand who understood that concept. Honestly, please raise your hand. I want you all to understand the concept. That's all I want. If you have any doubts, please put your doubts in the chat box. Okay, right. It seems you don't have any doubts, eh? Right. Okay, now if you go for the tutorial, page number 42, let's write down under the atomic radius, write down in this way. As the atomic radius increases, under the atomic radius, write down with me. As the atomic radius increases, first ionization energy, if not, we can tell that I1, first ionization energy, I1 decreases. Remember students, in your resource book also they have mentioned, we call sometimes the shielding effect is also affecting to the radius, ionization energy. Yeah, that's correct. Because if the atomic radius is affecting to the ionization energy, shielding effect also should affect to the ionization energy. The reason is, under the atomic radius, we discussed that the two factors affecting to the radius is what? Shielding effect and the nuclear charge. So if the radius is affecting to the ionization energy, so won't the shielding effect there? Definitely shielding effect will affect there, right? So therefore, let me write down here, since the shielding effect is affecting to the radius, to the atomic radius, it is affecting to ionization energy as well. Right? For example, I can tell you that I'll take, in order to explain that shielding effect scenario, look at this one. If I consider lithium and sodium, which one has the highest radius? Let's consider shielding effect. Shielding effect is number of co-electrons. Let me take S. Shielding effect means S, huh? Right. So number of co-electrons in the lithium atom, We know that in the inner shell there are 2 electrons, and if you consider our sodium atom, there are 8 electrons. So you can say that who has the highest shielding effect? Sodium. Sodium has the highest shielding effect. So if the sodium has the highest shielding effect, what will happen to the ionization energy? Ionization energy is reducing. Understood? Because shielding effect is affecting back to the radius, right? So if you consider shielding effect is also inversely proportional to the ionization energy I1, right? Which means if the shielding effect is very high, ionization energy is very low, or vice versa. Try to understand that is very simple, okay? Right. You don't have to write down these things. This definition is enough. This explanation is enough. You don't have to write down. If you want to copy down these things, okay, take your books or any kind of papers and write down these things, okay? Not everything you want to write down, right? Because I'm giving the tutorial, you to write down the important things. That is enough. For your additional knowledge, you can refer these things. So if you want to go through the first unit from the beginning again, from the introduction session, I have uploaded all the recordings to my YouTube channel. So go there and refer from the beginning if you want, or any missing parts were there, any missing parts you want to cover, don't worry, recordings are available in my YouTube channel. You can refer them, okay? I do this one only for the first unit. For the second unit and third unit, I won't upload the recordings for the YouTube channel. But I will have always my recordings. If you want, as my theory student, you can refer them anytime. Don't worry, right? In order to get an idea about our class, I have uploaded all the recordings until now I have done for your batch in the YouTube channel. You can go there and refer missing parts and everything. You can refer them, right? And tell your friends also, doesn't matter. They can freely get the recordings of the first unit because all of them have uploaded in the YouTube channel, right? And from the second unit, third unit, I won't upload everything in the YouTube channel. Okay. මොකද දැන් ෆස්ට් නයිට් එකේ රෙකෝඩින් ටික නිකන් වගේ හම්බ වෙනවා කියලා කියන්නේ ඒක මට ලොකු ප්‍රශ්නයක් නෙවෙයි ඉතින්. දැන් සමහර කට්ටිය රෙකෝඩින් පර්චේස් කරනවානේ, right? So ගොඩක් ගුරු රෙකෝඩින් පර්චේස් කරන් දීලා තියෙනවා. මාත් එහෙම කරනවා, right? අර නිකන් දෙන්න පුළුවන් හැබැයි අර නිකන් දුන්නම අගයක් නැහැ. දන්නවද? අර ලංකාවේ මිනිසුන්ට කතාවක් තියෙන නිකන් දුන්නම අගයක් නැහැ කියලා. ඒකද නිකන් දෙන්න බෑ කොහොමවත්. හරි? ෆස්ට් යුනිට් එක විතරක් ගන්න. If you want for theory students, you can get the recordings anytime, doesn't matter, okay? I'm talking about the others. If someone is coming from outside, right? Some people are depending only on the recordings. That's the thing. For you people, you can refer anytime recording. So you have to ask the recordings from me, right? I'll give you that. Right, okay. This is the way how radius is affecting to the atomic radius. Ionization energy, sorry. Now let's go for the electron configuration. This is very, very important, right? Okay. Shall I erase this one? Are we done? Right. So the next factor affecting to the ionization energy is electron configuration. Let's see. If the electron configuration is very much stable, what will happen to the ionization energy as you think? Now you know that helium, neon, argon, right? So these kind of elements have the stable configuration. 1s2, neon, 1s2, 2s2, 2p6. Argon is 1s2, 2s2, 2p6. 3s2, 3p6, right? So these are the elements. These are the noble gas elements. What you can say about these electron configurations? What you can say about these electron configurations? These electron configurations are perfectly stable. Very stable, yes. These electron configurations are very stable, perfectly stable. If they are stable, right? What does mean by a stable configuration? Stable configuration means it won't change again. Now, if you consider sodium, sodium is not stable. Therefore, sodium is forming sodium plus cation. Magnesium is not stable as much as noble gases. Therefore, it's forming Mg2 plus. Aluminium is not stable. Therefore, it's forming aluminium 3 plus. But neon, is it forming cations? Helium, is it forming cations and ions? Argon, is it forming cations and ions? Have you heard that one? As a chemist student, no, right? They are not forming because they are perfectly stable. Perfectly stable. If they are perfectly stable, how you can remove one electron? How you can remove one electron from this stable configuration? Right? How you can remove one electron from the neon? How we can remove an electron from the argon? Is it possible? Yeah, it is possible. But we have to supply a lot of energy. Right? We have to supply a lot of energy. That means helium, neon, argon-like elements have the highest ionization energy. If you consider the group wise, group 1, group 2, group 3, likewise, if you consider only the S and P block without considering D block, because in your resource book, they have given the ionization energy graph only related to the S block and P block elements, not for the D block. So therefore, group 1, group 2, group 13, 14, 15, 16, 17, 18, if you consider group wise, which group has the highest ionization energy? Group number 18. Can you tell me which group has the least ionization energy? Group number 1. Why? There is only one electron in the valence shell. Tag gala galala gatta. Ekai inne eka wedala gatta. Right? So you can just pull the last electron in the valence shell from the group 1 elements. So I proved that one already, right? If you consider the elements, the second period elements, so these are the second period elements. Right? If you consider the elements in this way, okay, lithium, beryllium, boron, carbon, nitrogen, nitrogen, oxygen, fluorine, and neon. Right? Look at this. Along the period, atomic radius is decreasing. I told you that how that radius is affected by ionization energy. Ionization energy is increasing. Right? Along the period, radius is decreasing. Therefore, ionization energy is increasing. So therefore, you can see that neon has the highest first ionization energy in that period. Right? If you consider the next period is sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. For them also same thing. Same thing is repeating. Argon has the highest ionization energy, first ionization energy in the same period. Right? If you consider the same period elements, what will happen? Lithium has the least first ionization energy. Neon has the highest first ionization energy. So it is proven here. Electron configuration is also affecting the another. Neon has the highest ionization energy because its radius also very low in that period, and its configuration is also very stable. Therefore, it has the highest first ionization energy. Two factors are affecting: electron configuration and the radius. Sir, what about beryllium? Sir, what about nitrogen? They also have somewhat stable configurations neither. So we can remember that you told like that they also have somewhat stable configurations. Yeah, wait. I'm coming to that point a little while. Okay, wait. Now, can you understand how that electron configuration is affecting to the radius? Ionization energy, sorry, ionization energy. When the electron configuration is stabilized, we can consider that ionization energy is very high. Okay, ionization energy is very high. So that's what you have to understand regarding the electron configuration and the ionization energy. Definitely, we are going to draw a graph today. When we are analyzing that graph, you will understand helium, neon, and argon, all the noble gases always on the top of that period in the ionization energy graph. So you will notice that. Okay, right. So try to understand this one. Students, give me 2 minutes. Okay, give me 2 minutes. Right, okay. So under the electron configuration, write down in this way. If you have any doubts, put your doubts in the chat box quickly. Sir, can you find unstable atoms in their unstable form in nature, or do they always form ions? Remember, for elements, so that's why we talk about the isotopes, right? In isotopes, we are learning that for a particular element, unstable isotopes are there, stable isotopes are there, right? For an element, there can be unstable forms also, not only the isotopes. If you consider the atoms, ions formed by those things. So unstable things are there in the nature. But they actually what? A little amount comparatively to the other ones. Now, for example, if you consider oxygen and ozone, right? So there are two main allotropes of oxygen. Allotropes means what? Same element but different forms, different physical forms. So oxygen and ozone is there. Oxygen is the most stable one. Ozone is also there in the nature, right? So which one has the highest in our atmosphere? Right, in our earth crust, in here in atmosphere, oxygen is the most stable one. Ozone is unstable. So we have ozone layer, yeah. So there is a different case, right? I'm talking about in the nature. So in the surrounding that we can see here, right? So their oxygen is stable. So likewise, unstable things are there in the nature, but they are little amount, right? So the amount is very less. Okay. Now, if you consider some elements like what uranium, they are also unstable, right? So those kind of francium, radium, astatine, radon, those are also unstable, but still they are existing in the nature, but they will decay by the time. The amount is actually reducing, or the amount that existing in the nature is very less. Okay, it can be in the any form, right? Ion, atom, molecule, anything. Okay, Diani, can you understand? Right. Write down the explanation for the electron configuration with me under the electron configuration. The first ionization energy, the first, so let's write down simply I1, the first ionization energy increases as the electron configuration stabilizes. The highest first ionization energy of atoms is formed by found in atoms, is found in atoms with the lowest atomic radius and most stable configuration. Most stable electron configuration. Therefore, this has the highest ionization energy, first ionization energy in the periodic table. Fill in the blanks. Okay, when I turn, I should see the answers. Who has the highest first ionization energy in the periodic table? Let's see your answers. No, I need the element. Lakshmi, correct. Tashani, Opeshani, correct. Zeena, wrong. Sandeep, correct. Ammar, correct. Nilukshika, I want the element. Shahala, correct. I want the element. Senora, correct. Who is that? I told you that when the atomic radius is very low and the electron configuration is very stable, the ionization energy is very high. Right? You have to consider both the factors. Lowest radius and the highest stabilized atom. Helium. In the periodic table, we know that the smallest element is helium. We know that definitely we have to go for the first period. Definitely second period, third element, the third period, fourth period elements, since the number of energy levels are increasing down to the group, radius is increasing. At the beginning, I explained that one, right? So therefore, definitely the first period element should have the least radius. But when you compare the first group elements, we have only two, hydrogen and helium. Among them, who has the least radius? Helium. Because along the period, radius is decreasing. And who has the stable configuration, hydrogen or helium? Helium again. And therefore, the highest first ionization energy belongs to the helium in the periodic table. Remember students, very, very important now. The highest first ionization energy belongs to the helium in the periodic table. Got it? Okay. Write down this one. Right. And then they have given, look at this one, simple A, variation of the first ionization energy along a group. The first ionization energy decreases as it descends from top to bottom on any group in the periodic table. Yeah, as I mentioned you, I explained you what will happen to the first ionization energy down to the group first ionization energy is decreasing, right? So they have given some space there. So let's write down there quickly in this way. Simple A under that one. The electron configuration does not affect the first ionization energy, does not affect to first ionization energy along a group because valence electron configuration of the elements in the same group is considered to be the same. Remember students, if you consider the elements in the same group, we don't have to consider the electron configuration. Why? What is the reason? We know that if you consider the same group elements, let's consider lithium, sodium, potassium, rubidium, cesium, their valence configurations are, I'm not going to write down the complete configuration, only valence configuration. So this is what? 1:2, 2s1, 3s1, 4s1, 5s1, 6s1. Their valence configuration is always same, s1, 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 right? So now tell me, down to the group, that means in a group, for the elements in the group, electron configuration is not the affecting factor. Then only the radius. Then, sir, in which cases the electron configurations are affecting? Along the period. Because along the period, from element to element, electron configurations are completely different. So that's what meant by this statement. The electron configuration does not affect to the ionization energy, first ionization energy, along a group because valence electron configuration of the elements in the same group is considered to be the same. Try to understand. Very easy. Okay. Quickly complete that one. quickly. Right. Okay. Now they have given, as the atomic radius increases, as a group descends, the first ionization energy decreases. I told you that down to the group ionization energy decreases. That's what meant by this statement. Now simple B, they have given variation of the first ionization energy along a period. Consider the variation of the first ionization energy of the short period element with 8 elements each, right? So let's consider let's consider elements in a short period. Okay, short period means with 8 elements. Okay, right. Let's see. So this is the most important thing that we have to learn. So these are the elements in the second period. What is the configuration of lithium? 1:2:1. Beryllium is 1:2:2. Boron 1:2:2, 2p1. Carbon is 1:2:2, 2p2. Nitrogen is 1:2:2, 2p3. Oxygen is 2p4. Fluorine 2p5. Neon 2p6. Right. Now these are the elements along a period from left to right. So how should the ionization energy vary along a period? As I mentioned you, right? Since the radius is decreasing, ionization energy should increase. Right? If we consider the elements lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So these are the elements, right? And this is the first ionization energy measured by kilojoules per mole, right? So I'm going to draw a simple graph and I'll let you know how that ionization energy will vary. This is very important, huh? Very, very important. Now, lithium. So along the period, we know that radius is decreasing in this way. In this way, radius is decreasing. When the radius is decreasing, what should happen to the ionization energy? Ionization energy should increase. Am I right? Ionization energy should increase. Can you understand that? In this way. Right? Beryllium is here. Boron is here. Carbon, nitrogen, oxygen, fluorine, and neon. The neon comes here. In this way, the radius should decrease and ionization energy is increasing. Right? This is the way. Students, when I'm drawing this graph, you can see that I have considered only the radius. I didn't give the priority for the electron configuration. So what are the electron configurations? 2s1, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Among these electron configuration, which one is the most stable one? Neon. That's okay, fine. Neon is the stable one, the most stable one. If you consider beryllium and nitrogen, they are also somewhat stable. Beryllium, all the sub-energy levels are completely filled with the electrons. If you consider nitrogen, this is half stable, because in the p sub-energy level, there are 3 electrons. All the orbitals are completely filled with 1 electron, a symmetrical order. So therefore, that is also stable. Ne? So therefore, okay, neon's configuration, okay, because neon has the highest first energy. Now, remember students, this is not the correct variation. This is not the correct variation. So we can tell that this is the expected variation. This is the expected variation of the first energy. Right? In the tutorial I have given you, right, finally expected variation and the exact variation. The exact variation of the ionization energy is look like this. Look at this one, very important, right? Lithium here, beryllium here, okay? Lithium, beryllium. I'll draw that one here. Lithium, beryllium. Boron. Okay. I'll draw that separately. Let's see that one. Because if I draw that one with this one, actually you will confuse, right? Look at this one. This is the expected variation. You are expecting that ionization energy should gradually increase, right? So let's see how is the correct variation. How is the exact variation? Lithium, beryllium, boron, carbon, and nitrogen, oxygen, fluorine, neon. Look at this variation. What is this? This is kind of a zigzag variation, right? So this is the exact variation. This is the exact variation. This is the exact variation of the first ionization energy, right? This is the exact variation of the first ionization energy, right? Can you remember previously I drew here previously what? Expected variation. Expected variation was like this. Gradually, it's gradually increasing in this way. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, in this way, right? So this is the expected variation. Expected variation and the exact variation, right? Where the differences occurred? Beryllium and carbon, we expected that boron has the highest first ionization energy than the beryllium. But here we can see that beryllium's first ionization energy suddenly increased. What is the reason? Electron configuration. When you compare the beryllium and carbon, beryllium has stable configuration than boron. So that's why beryllium has suddenly increased. Carbon, boron, carbon, okay, fine. Okay. Nitrogen again increased than the oxygen one. This is oxygen, right? This is oxygen. Lithium, beryllium, boron, carbon, nitrogen, oxygen. Nitrogen configuration is stable than the oxygen's one. Nitrogen again is increased. Fluorine and the neon is anyhow the greatest one. Neon is the greatest one. Anyhow, that is the greatest one. Can you understand? Can you understand why this kind of an unexpected variation occurred? Because of the stability of the electron configuration. We expected that since the radius is decreasing along the period, ionization energy should increase gradually. But unexpectedly, since beryllium and nitrogen have stable configurations with the surrounding elements, we can consider that they have some stable and highest ionization energies. Right? Beryllium, nitrogen. Okay. Look at the graph, analyze the graph. What kind of a variation is this? This variation is known as zigzag variation, right? This is very famous, right? This is very famous. We consider this one as zigzag variation. This is the zigzag variation of the ionization energy. Exact variation and the expected variation. So you have to remember this one, right? You have to remember this one. When you go for the questions, you have to remember this one. This is the way of varying the ionization energy. Please raise your hand who understood this. Please raise your hand. Please raise your hand who understood this. Ammar and Michelle. Okay, good. Right. Okay. Then what we have to do, turn to the page number 43. Yeah, we have some doubts. Let's see. So even though the valence electrons are same, the electron configuration isn't same now. So electron configuration does affect now. Even though the valence electrons are same, the electron configuration isn't same. Yeah, okay. So electron configuration does not affect. Does affect now. No. Yeah. I meant there, actually that should be corrected as the stability, right? In the stability wise, Senura, in the stability wise, electron configuration is not same, right? If you consider lithium, sodium, potassium, their electron configurations are different, correct? That's correct. But the stability wise, I meant there, try to understand what I meant there. So you can correct that one. In stability wise, the electron configuration is not effective, right? Okay, that's a good point. Try to understand in the stability wise, electron configuration is not affecting to the down to group. In the same group elements, stability of the electron configuration is not affecting, right? Electron configuration is affecting, yeah, that's correct, because what number of energy levels are increasing, therefore electron configuration is increasing. But I meant there stability of the configuration, right? If you consider the valence shell electrons are same. So therefore electron configuration is look like same, right? So therefore stability wise, the electron configuration is not effective, right? Try to understand what I mean. So you're okay? Done. Okay. Now, what you have to do here is Uh, now you have to draw this graph in the given space in the page number 43, right? So you have to write down this one as S1, S2. This is S2P1, S2P2, S2P3, S2P4, S2P5, and S2P6. Okay. We have to write down a paragraph. I saw that in the page number 43, I have to write down a paragraph. But before I draw that one, please draw this graph with this radius and everything. Please draw this one nicely, quickly. Draw this one. Quickly, yeah. Quickly draw this one. right? Please quickly draw this one. You have to remember this variation, okay? When you ask to compare the ionization energy, quickly you should be able to draw this kind of a graph. Very easy. Lithium, beryllium, boron. Beryllium is suddenly increasing. Boron, carbon, nitrogen is what? A uniform increment, and suddenly it drops to oxygen, and fluorine neon is increasing, right? Quickly draw this one. Done, right? Right, okay. Now you can write down here expected variation and the exact variation. So what is the expected variation? I'll write down here the group wise expected variation. Expected variation is, we expected that second group element have the highest first energy than the first one, then 3, 4, sorry, not 3, group number 13, 14, 15, 16, 17, 18. This is the way that we expected, uniform increment, right? But the exact variation, right? In the tutorial, I have given you the expected variation and the exact variation. So the exact variation is 1, then 13, 2, right? Then group number 14, right? And then group number 16 come here, and 15 is greater, then 17, 18. So this is the exact variation. So here the exact variation is taking place because of the stability of this second group and the group number 15 configuration, right? Because of the stable configurations, right? Quickly write down. Right, okay. Shall I erase this one? Shall I erase this graph and everything? You all okay? Okay. Right. Now write down with me. In the page number 43, I have given you space. In that given space, write down in this way. The first ionization energy, the I1, can be expected. Can be expected to increase as atomic radius decreases along a short period. Remember, students, in our syllabus, they have given us to analyze only the ionization energy, variation of the ionization energy along a short period. That means second and third periods. Only the second and third periods. We don't go for the fourth and fifth, because if we go for them, actually we have to go for the D energy levels also, right? So therefore, we are analyzing only the second and third. The ionization energy can be expected to increase as the atomic radius decreases along a short period. However, ionization energy does not uniformly increase along a period as some elements have stable electron configurations. What are those elements? Those elements are beryllium, write down in bracket, beryllium, nitrogen, magnesium, and phosphorus in the second and third period. However, first ionization energy does not uniformly increase along a period as some elements have stable electron configuration. Beryllium, nitrogen, magnesium, and phosphorus. Right. We can observe, write down, we can observe zigzag variation. We can observe zigzag variation of the first ionization energy along a period. Zigzag variation. So this is very important. Zigzag variation. Okay. Right. Complete the note quickly. So that expected variation and the exact variation that I gave you with the group numbers. I gave you the group numbers. Those are group numbers. Okay. Right, okay. Are we done? Shall I erase this one? Now turn to the next page. In the next page, they have given you a question, right? They're asking, sketch the first ionization energy graph of consecutive elements from hydrogen to argon. So hydrogen to argon, remember students, this graph is really, really important. Hereafter, uh, you should be able to draw this graph if I ask you to draw that one. In the paper discussion, I will give you many questions regarding the ionization energy. Then you should be quickly draw that graph by yourself. So therefore, hereafter you have to practice to draw this graph. Huh? Very, very important. Look at this. I told you that the highest first ionization energy is always belong to who? Helium. Therefore, always helium is the highest point. And then we have lithium. So they have asked us to draw the ionization energy graph from hydrogen to argon only, right? Hydrogen to argon only. Then I can take lithium in here. Lithium. Look at the way that I'm drawing the graph. Huh? Helium and lithium. Then we have beryllium, boron, nitrogen, carbon, nitrogen. Then here we have oxygen. In your resource book, they have given students, remember, this is very important. Oxygen and hydrogen, both the elements are in the same horizontal plane. That means, according to the diagram they have given in your resource book, hydrogen and oxygen are in the same horizontal plane. That means they look like similar. Okay. Now, oxygen, right? Then fluorine, neon. Fluorine and neon. Fluorine and neon. Neon. Again, you can see the same pattern, right? Again, you can see the same pattern in sodium. Right? Now we are done with the second period elements. Now we are coming back to the third period elements. Sodium, magnesium, aluminium, right? Aluminium, silicon, phosphorus, sulfur, chlorine, argon. If you want, you can go for the potassium and calcium as well. In this, here we have potassium and calcium. Can you understand? The same zigzag variation is repeating in the third period also. The same zigzag variation is repeating in the third period also, right? Okay. So hydrogen, let's put that one in the plane of same the value for the oxygen. Right. Okay. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Right? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. If we want potassium and calcium. Can you see that? As I mentioned you, beryllium, look at this one, beryllium and nitrogen is showing exceptional behavior because of their stable configuration. Phosphorus and magnesium, they are also showing an exceptional behavior because their electron configuration are stable. Right? So the same zigzag variation is repeating to the third period also. Can you understand? Right? Look at helium, neon, argon. I told you that down to the group ionization energy is decreasing. You can see that one. Right? Helium, neon, argon. Decreasing, right? Helium there, neon here, argon here. You can see that one from the lithium, sodium, potassium also. Right? Lithium has the highest first energy. Sodium has the second highest one. Potassium is the least one. Down to the group, first energy is decreasing. You can analyze that one inside this graph. And then this zigzag variation is occurring because of the beryllium and nitrogen. That means S2P2 configuration and S2P3 configuration. Sorry, this is a beryllium. Beryllium means S2 configuration. Nitrogen means S2P3 configuration. Magnesium S2 configuration. Phosphorus is S2P3 configuration. Because of their electron configurations are stable, they are showing high ionization energies than the surrounding atoms. Magnesium, aluminum, we are expecting that aluminum should have the highest value, but magnesium has the highest value. Look at the variation. You have to remember this variation, very, very important. Sir, can we compare the second period elements and the third period elements? Yeah, we can compare, but don't go for that one. So in the questions, let's discuss how to compare the second and third period elements separately. That means whether phosphorus is high or fluorine is high. Likewise, if they have the questions, then I'll explain that one. You when we are doing the questions, let's discuss that one. Now you have to compare how to get the ionization energy in a same period. This is the variation. This is the variation for the second period. This is the variation for the third period. Likewise, you should be able to compare the radius. So this is third period. Right? This is third period. Okay. And here you can see, what about this one? This is second period. And among these elements, which one is the highest one? Always helium. Always helium has the highest first ionization energy. Right. Now you can ask your doubts. What are your doubts? Please raise your hand who understood everything that I taught you here. You have to remember this one, right? Please raise your hand who understood. Let me see. So what about the others? I want to see the names. Shahala, Michelle, Madhurukshan. Yes. What are the doubts you have? Good. Right. Please don't tell that you understood everything. Yeah, we have a doubt. So does atomic radius affect only first along a group? Yeah, atomic radius. No, we can't say only. Atomic radius is affecting to the period wise also. It's affecting, right? Period wise also it's affecting, because if you consider lithium to neon, so neon has the least radius, right? Lithium has the highest radius in that second group. So therefore, uh, period wise also radius is affecting. But if you go for the group wise, only the affecting factor is radius. We don't have to worry about the electron configuration. Can you understand? I think that's what you meant. If you consider the group wise elements, do we need to consider the radius? No. Right? If you go for the period wise, do we need to consider the radius? Yes, we have to. And plus electron configuration. In the group wise, we don't have to consider the electron configuration. Can you understand? Gimani? Yeah, that's a good question. Right. Okay. Now, quickly copy down. Quickly copy down this one. Okay, are you done? Do you need more time? Done, eh? Okay, right. So if you didn't complete this one, quickly take a screenshot of a photograph, and later you can draw this up, right? Right. Okay. Right. Now look at this one, okay? So now you have drawn the first ionization energy for the until Agani. That means for the second period and third period, you have drawn the ionization energy. Now you have a little bit idea. So using that idea, tell me the answers for this one, right? Let's see how you understood this one. I1, I2, I3. I'll consider these are consecutive ionization energies. That means first ionization energy, second ionization energy, and the third ionization energy. So we only learn about first ionization energy. But don't worry, if you know the first ionization energy, you will be able to derive the second ionization energy and the third ionization energy, right? So today as a homework, I'm going to give you that one in order to do that homework. This will be very helpful for you, right? Lowest in group, highest in group, right? Now carefully, I need the correct answers. When you draw the ionization energy graph, except hydrogen and helium, this is the way. Okay, let's include the helium also. Helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So likewise, you should be able to draw this one quickly, right? Look at the way I'm going to draw that one. Sodium, magnesium, helium, neon, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Right. Now, this is the first ionization energy graph that you drew. Students, tell me, the lowest first ionization energy always belong to the which group? Group number 1, no, group number 2, no, 13, no, 14, no, 15, what? What is that one? Correct. Sarina, correct. Sandeep, correct. What about the others? Correct. Very good. All of you, send me the answers. Before I name you, send me the answers, right? If not, I will name you. Right? According to this graph, when you're analyzing this graph, which group has the always the least first ionization energy? In which group? Lithium and sodium is belong to the group number 1. Right? Always lithium and sodium has the least ionization energy. That means the first group elements always having the lowest ionization energy. Then tell me the highest ionization energy. Highest first ionization energies always belong to the which group? Annahari, group number 18. That is group number 18. Very good. Group number 18. Now let's go for the second ionization. Now let's go for the second ionization. So you didn't teach us to derive the second ionization energy. Very easy. Very easy, students. Don't worry. This is really easy. Do you know what? Do you know what you have to do? You have to push this first ionization energy graph to the elements, right? You are going to push these elements, right? You are going to push these elements to the left hand side. Then you will obtain the second ionization energy. So we didn't get it. Very easy. Put lithium here. Now lithium here. Put beryllium here. Boron here. Carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium. So what is that? How did you tell that when we push the elements to the left hand side, we will derive the second ionization energy graph? Very easy. The lowest first ionization energy belong to the first group elements, because lithium, sodium, potassium, all of them have the electron configuration, valence configuration 2s1, 3s1, 4s1. Therefore, we can easily remove the electrons. That's why we consider the lowest first ionization energy belong to the first group. Then, according to that rule, the lowest second ionization is belong to the second group. Beryllium, magnesium. Is that correct? Yes. Beryllium is 2s2. Magnesium is 3s2. Calcium is 4s2. So 4s2 means you can easily remove the 2 electrons. Correct, ne? Can you see that? Can you see how did I derive that second ionization energy? I shifted these elements to the left hand side. In the first ionization energy graph, helium was there, right? Now, into the helium position, now lithium is came. This is the second ionization energy graph. Now then you should be able to tell which group elements have the lowest second ionization energy. Tell me, which group elements? Definitely group 2. Yes, correct. Definitely, second group elements has the lowest second ionization energy. Now tell me, in which group elements has the highest second ionization energy? First group elements. How is that? How is that? Look at this one first. When you analyze the graph, now you can see that on the top, right? In the top places, you can see lithium, potassium, sodium, potassium. Right? I can explain that one using the electron configuration also. Now look at this one. Sodium second ionization energy means sodium's electron configuration is 11, 1s2, 2s2, 2p6, 3s1. Second ionization energy means after removing one electron, you are trying to remove another electron. Students, after removing one electron from the sodium atom, now the configuration is 1s2, 2s2, 2p6. So this is like neon's configuration. This is stable configuration. How you would remove electron from this one? You have to supply a lot of energy. That's why we consider that second ionization energy for the group 1 elements are the highest. Can you understand? After removing one electron, now sodium has the what? Neon's configuration. From the neon's configuration, you can't remove electrons. That's very difficult. That's why we can see that in the graph, top of the graph, lithium, sodium, potassium. Right? Now, the least second ionization energy belong to the group 2 elements. Highest second ionization energy belong to the first group elements. Now, my next question is, what is the next question? third ionization energy. Third ionization energy. When you go for the third ionization energy without drawing a graph, right? Imagine these things in your mind. Tell me which group elements has the least third energy. Wrong, completely wrong. All of you are wrong. දැන් මෙච්චර උගන්නලා තියෙන මම බලපයින් හරි මොනවද මේ දාලා දෙන උත්තර chat box එකේ group number 3 කියලා එකක් කියලා දුන්නාද මම did I teach you group number 3 something like that what are you saying be mature right group number 13 group number 13 not group number 3 group number 3 belongs to the D block we are talking about the short periods second and third so therefore group number 13 right so the lowest third ionization energy belongs to the group number 13 the lowest third ionization energy belongs to the group number 13 that means again this graph is these elements are shifting to the left hand side that means beryllium should come here now look at the graph beryllium should come here carbon should come here right beryllium sorry lithium beryllium boron carbon nitrogen oxygen fluorine neon sodium here magnesium right and here we have aluminium silicon right according to the graph you can see that the least ionization energies are belong to the group number 13 elements boron and aluminium right boron and aluminium are group number 13 elements therefore the least third ionization energy belongs to the group number 13 elements now tell me then which group elements have the highest third ionization energy exactly group number 2 can you understand so by analyzing the first ionization energy we can derive the second and third also remember students this is practically not correct right practically මේ values ටික පොඩ්ඩක් එහා මෙහා වෙන්න පුළුවන් ඇත්තටම මේකම නෙමෙයි අපිට එන්නේ but we can say that theoretically okay theoretically if you ask to derive the second ionization energy graph or third ionization energy graph this is the way that you are going to derive that right so now let's take magnesium is 12 1s2 2s2 2p6 3s2 when you consider the magnesium's third ionization energy you have to remove these 2 electrons and you are trying to remove another electron from this is the configuration of neon is it possible to remove 1 electron from the neon's configuration no that's why we consider magnesium's third ionization energy is greater compared to the other group elements can you understand so again without drawing a graph tell me students in this way who has the lowest fourth ionization energy in which group very easy group number 14 right group number 14 now tell me in which group elements has the highest fourth ionization energy yes group number 13 can you see the pattern right pattern right this is the way you are analyzing the ionization energy graph I'm very sure that even in your schools they won't teach the ionization energy graph in this way right please take 1 hour or 2 hour at home and try to analyze this one again I know that now in the class you can understand this one perfectly because I'm explaining this one right so you have my guidance here right but remember within 1 No. Yeah. Within one night, you will forget these things. Right? You will wake up tomorrow morning and sometime you will forget everything. Sometimes, yeah, you can forget, you can remember a few things. It doesn't normally you can remember that in one night. So within 1 week, you will forget everything totally. So therefore, you have to practice this one. Take your time again tomorrow morning. Take some piece of papers and try this one. Try to draw this one by you alone, right? And analyze what is this exact, right? First of all, think about the things that Sir taught is correct or not, right? So how this happens, like think about this one, analyze this one, argue with yourself. Then you will understand these things properly. You can put these things to your mind, right? So remember, we should be able to derive the second ionization energy graph and the third ionization energy graph by looking at the first energy graph. Now I taught you the first energy graph. So therefore, as a homework, turn to the page number 44. And one more thing I want to remind you here, in the page number 44, 45, I have given you some graph because students, these graphs are exactly, I extracted these graphs from your resource book. I told you the reason why I am taking these graphs. For the 24 batch, I didn't give these graphs. For you people, I giving this one because I'm giving this one. Because normally if they are giving a graph question in the examination, probably they will choose a graph from the resource book, right? We can find many graphs from many books and internets. We can find them and put in the tutorial, but no use. So therefore, I thought to give this exactly similar graph for you. So at home, analyze these graphs. If you have the resource book, you have already seen these graphs. So please analyze these graphs and try to get an idea how the variation happens, right? So in the page number 45 or 44, analyze those things, and that is also kind of homework that you can do. And in the page number 46, look at the page number 46. Sketch the first, second, and third ionization energies of consecutive elements from lithium to argon in the same graph. You have to draw this one. That means you have to draw 3 graphs in the page. That means in the same plane, right? So lithium to argon, right? Lithium to argon. That means you cannot change the shape. I will send you a picture after the class. I'll send you the picture, the graph that I've drawn, right? So kind of a graph, right? But that is not perfect. You have to name the elements and everything. So draw that kind of 3 graphs in the same plane. First ionization energy, second ionization energy, and the third ionization energy. So do that one as a homework after today's class, right? Okay. First of all, tell me, can you understand how to derive the second and third, fourth consecutive ionization energy graph in this way? What do you have to do? You have to shift the elements to the left-hand side. We had helium here in the first ionization energy graph, and we put lithium here, then only we obtain the second ionization energy. And then when we put beryllium here, then we can obtain the third ionization energy graph. So after putting beryllium, boron, carbon, hydrogen, likewise we can. That's the way, very simple, right? I will send you a small graph that I've drawn, then you can understand that, right? That means you have to put you have to take the x-axis as lithium, beryllium, boron, carbon. You can't change them, but you have to draw the graph. Let's see. That's a nice exercise for you, right? Let's see how you are going to do that. Okay. Please raise your hand who understood this. That means if you have, first of all, tell me if you have any doubts, put your doubts in the chat box. I will answer you. Because this is all about the ionization energy. Ionization energy is also finished. Any doubts? Very easy. Don't think about that much. You have to remember that variations, exact variation. That's all. Okay, right. Please note down this graph in the additional notes. Page number 51. Under the additional note, write down this graph quickly. Page number 51, additional note, write down this. Yeah, I think we have a doubt. So is that means we should keep the elements in the same point or the change the elements in the same graph? No, Sinetma, you have to keep the elements in the same point and shift the graph. You have to keep the elements in the same point and the shift the graph. Okay, that's what you have to do. Where will hydrogen will be shifted for third and fourth energy graph? You don't have to worry about hydrogen and helium. I ask you to draw the ionization energy graph starting from the lithium, right? Lithium to argon is enough. Don't worry about the hydrogen and helium, right? Because we can't derive where hydrogen and helium is shifting. Okay, so that's why I ignore the hydrogen and helium. Draw the ionization energy from lithium to argon. You can't change the point of the elements. Huh? Lithium here means lithium here, right? So, sir, when we go for the second ionization energy graph or the third ionization energy graph, we have to consider that now if you go for the third ionization energy graph, where is the lithium? Yeah, in the third ionization energy graph, lithium is missing because you are shifting it, right? So I will send you an image, right? Then you will understand, right? I know that most of you can't understand when I'm saying this one. I'll send you a nice image, then you will understand. Okay, don't worry. Soon after the class, I'll send you that image, right? So if two electrons going to remove from the magnesium, it is equal to neon. Okay, yes. So how the highest group gonna do? What is that? I gonna understand. So if two electrons are going to remove magnesium and it's equal to neon configuration. So how the highest in group gonna do? I'm talking about the third ionization energy. I'm talking about the third ionization energy. Who's person? Yeah, Senura. Third ionization energy means you are going to remove three electrons, right? You are going to remove three electrons. I'm not talking about only the magnesium. I'm talking about beryllium as well, right? Beryllium and magnesium group wise, not only particular magnesium. I'm commonly take magnesium, right? If you compare the elements in the second period, third period, we can take magnesium. Magnesium configuration is 1:2, 2:2, 2p6, 3s2. After removing these two electrons, it's very difficult to remove electron from this. In the same way, I can tell beryllium 1s2, 2s2. After removing these two electrons, it's very difficult to remove an electron from here. I can write down the same thing for calcium also 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. After removing two electrons, when you are trying to remove the third electron, it's very difficult. That's why I told you the highest third ionization energies are belong to the second period elements: beryllium, magnesium, calcium. Among them, beryllium has the highest first ionization energy because the radius is very low. Can you understand, Sandra? Got it. Okay. Anything else you want to ask regarding the ionization energy? No, it seems you don't have any doubts. Okay, then can you remember the homework? What is the homework? The homework is draw the, in the page number 46, I have given you the question. Sketch the first, second, third ionization energy of consecutive elements from lithium to argon in the same graph. So that is the homework you have to do, right? Okay, now let's look at this one. The following points are important regarding the ionization energies of the elements at short periods. Okay, write down with me. Write down. In a short period, lowest first ionization energy, I1 belongs to group 1 elements. And elements comma lowest second ionization energy belongs to group 2 elements. And lowest third ionization energy belongs to group 13 elements. Second point, in a short period, highest first ionization energy belongs to group number 18 elements. Highest second ionization energy belongs to group 1 elements. And highest third ionization energy belongs to group 2 elements. So that table that we have drawn. Okay. complete this one quickly. Okay, right. So that is all about the ionization energy. If you have any doubts, you can ask me. Anything you want to ask? Anything? No doubts. Okay, right. Then we completed the atomic radius and the ionization energy. Now we have only two topics: electron gain energy and the electronegativity. Actually, we have only 1, 2, 3, only 4 pages to finish the unit, right? So now time is 10:05. Can you stay for a while, or what should I do? Can you stay for a half an hour? No response. What about the others? Okay, okay. Okay, right. It's okay, fine. I can understand you, right? So I want to sleep. Okay. Right, okay. We have a small part. So I think I can cover that one using a recording, right? Yeah, hungry. Okay, hungry, sleepy. Okay, right. Okay, I can understand. So who is that? Who told that hungry? Sarina. So Sarina, haven't you eaten for a long time? If you stay hungry for one night, what will happen? Will you vaporize? So it's okay, fine. Yeah, I can understand. You will die. Okay, right. Okay, it doesn't matter. So you can die for your future. Doesn't matter, right? So you can die for your future. What do you say? We are all hungry. Senor also saying hungry. Okay, right. Okay, right. මොනා කරන්නත් කාලා ඉන්න ඕනේ සර් නැත්තම් බෑ. හරි මාත් ඒක පිළිගන්නවා. හරි. හරි. Okay. So we have only two parts: electron gain energy and electronegativity, very small parts, and very important also. So shall I cover that one, use a recording, 1 hour recording, 1 hour or less than 1 hour recording, because I don't have to take the next week class to do that one. I'll put the recording by Tuesday, Wednesday again. So by Saturday you can go through that one, and we can cover the first and then we are completed with the first, right? And in the next Saturday, let's do kind of a speed revision or something. So that is not compulsory to attend. That means for all of you, if you can attend for that one, attend, doesn't matter. Better you attend, because that is 4 a day. Some of you are going for out ne, samara katte pansal ewana ne. So therefore, attend for that one. Sometimes I might put some speed revision or something from 6 p.m. to 10:30, 11 wage. Not continuously. I will give you some breaks. So from the beginning, I will revise everything. Okay, from the atomic, subatomic particles, cathode rays, and everything. I will give you a full revision, so we can revise. And in the following week, that means 4th of November. Yeah, November 4. So 4th of November, we can start second unit and third unit. So you will get the tutorials before 4th of November, right? So tutorials are ready. So that means 2 cover pages should come. So the tutorials are ready. I have to print them, and I'll send you that one very soon before the 4th of Saturday, November, right? So very happy to finish the first unit. I think when we started the classes, can you remember? අපි කවද ක්ලාස් පටන් ගත්තේ ජූනිද ජුලයිද? ජූනිද? ජූනි මැද වගේනේ. 3 months ago. June නේ. Yeah. June වල අන්තිම හරිය වෙලා පන්ති පටන් ගත්තේ හරි. ඒකට June වල පන්ති ගැන දැන් අපි ඉන්නේ හරි June අතල්ලා දානවා. අගෝස්තු, සැප්තැම්බර්, ඔක්තෝබර්. මාස 3කින් කවර් කරගත්තා කියලා කියන්නේ ඉතින් ලොකු දෙයක් ඇත්තම කියන්නේ මේක. So we covered this one within 3 months. Is actually that's a big deal, right? Because for the previous batch, I think I did a revision, kind of a revision, and in my physical batch, first physical batch is 23. So in that batch, actually, I spent there 5 months again. So I'm really happy that I covered everything within 3 months, right? So that's a good thing, right? Okay. So first one is covered. So go through the things, and can you remember the assignment? What is the assignment? So again, a reminder. Do the assignment on or before 28th, that means before Saturday, and submit that one. We are going to discuss the past papers of the first unit in Saturday evening 5 to 7 from the next month. And from the next month, Wednesday evening, we are taking 2 hours, right, to discuss a paper, small paper, right? So better you attend for that one, but I'm not forcing you, because you can't spend more time with the online classes. I know that. So I'm not forcing you. Anyway, I'm uploading the recording to the WhatsApp group. You can go through those things. So that's all, right? So if you have any doubts, let me know. Let's discuss the doubts and everything anytime. So sometimes when you're sending messages through WhatsApp, I'm not quickly sending you the answers. It will take some time, because some things are there, right? So I'm really busy. So therefore, you can send your doubts, right? So do we need to join for the past paper discussion group? No need. Past paper discussion group, no need. I'll upload everything to our theory group. Everything for you people. You can come to the recording. Maybe class. I'll upload that one to the group. No need a separate group. Okay. For the paper discussion, sometimes I might create a group. So I'll put the link, join for that one, because if someone is coming to the paper discussion outside Wednesday evening, they have to pay. For my theory students, that means for you all, you don't have to pay for that one, right? So that means hereafter we are spending 3 hours in Saturday, 5 hours in the Saturday, and 2 hours in the Wednesday. That means 7 hours for chemistry, right? So that's really good. That's very nice. And that means we are working. So we are working people, right? So therefore, that's good for you, right? Okay, then do the homework, send the homework, and I'll send you that photo, and I'll upload the recording for the remaining part, electron gain energy and electronegativity. Coming Saturday, the next Saturday, we are going to discuss a speed revision from the beginning. I'll send you a post for that one. And yeah, that's all. Then I'm going to wind up the session. So eat well, sleep well, study well, have fun, good night. Bye-bye. Okay, good night for all of you. God bless you.